This video will demonstrate the use of our dashboard, as well as the ways in which we answer our challenge questions. We'll cover the 9 challenge questions we used from Homework 2. These questions are inspired from the suggested challenge questions on the homework write-up. Our index data was collected from Seed 2, the ADE dataset. First, let's look at our D3 visualizations. We've developed 6 D3 visualizations: a bar graph, a bubble chart, a pie chart, a donut, a force-directed graph, and a map. Let's enter our first query and look at its dynamically generated bar chart. Our bar chart visualization shows each of the top 50 search results as a bar. The length of each bar is the relevancy score for that document as it pertains to this query. If we hover over the bars, we can see the titles of the corresponding documents. Now let's take a look at our bubble chart. A bubble chart is a type of graph which displays the most common words from a corpus. Each word is shown in its own bubble, and the size of each bubble is proportional to the number of times that word was found in the corpus. In our case, the corpus is the set of content fields extracted from our Solr search results. Next, we'll show our pie chart. Pie charts are used to show distributions of different things which sum up to a whole. What we have decided to use is the number of hyperlinks found on each document. To be more precise, we have different regions in our pie chart, and each of those corresponds to documents having between 0 and 49 hyperlinks, or 50 to 99 outgoing hyperlinks, etc. Donuts are another visualization tool which will show the relative proportion of different parts of a whole. We'll look at another query. For our donut visualizations, we are splitting up these different parts as follows. Each section of the donut corresponds to the number of keywords found in the documents of that section. Let's move on to our force-directed graph widget. In our graph, the different nodes represent different documents. We have limited the graph to just 100 nodes because, as we learned from the extra credit of Homework 2, force-directed graphs are not built to handle tens of thousands of nodes. We are using spatial connections between documents to determine the edges of the graphs. For each document, there is a list of latitudes and longitudes, obtained from Clavin before indexing in Homework 2. We create a link between two documents if they share a latitude-longitude pair. If we hover over a node, we can see the title of the document it corresponds to. So, We have many stray nodes here which have no links. These represent those documents which did not resolve any locations from Clavin. These could be images, videos, other files, or maybe small text files which just don't reference any geographic locations. In here we have many nodes which are linked to many of the other nodes around them. These are sharing common locations. Let's look at another one. We see similar phenomenon exhibited here. Finally, let's take a look at our map. We have a world map, and we use the GeoProjections D3 widget as a utility in order to help us render the map and project the latitude-longitude coordinates to the correct spots on the globe. Here we have dots scattered across the globe in Antarctica, Canada, the US, Mexico, Europe, Scandinavia, Russia, China, India, the oceans, Australia. Let's do some more map queries. Here we see a lot more dots trending towards the northern part of the globe, especially towards the poles. Let's do one last D3 map visualization query. Alright, now let's take a look at Banana. Banana is an analytics dashboard. It contains a lot of data about our solar index. Here we have a bar chart showing different content types and the amount of documents which have been indexed of those different document types. Similarly, we have a pie chart here representing similar info for keywords. Here we have a tag cloud, where the bigger the word appears in this cloud, the more occurrences it has in our corpus. Let's do a query. Notice that as we make the query, these fields begin to refine. The content type bar chart filtered itself to match the results which come back from this query. The same thing happens for the keywords and for the tag cloud. Now let's look at FacetView. FacetView allows for free text search along with faceting. We can refine our search in order to get more specific data for what we're looking for. I'll refine this query with two keywords, sea and ice. Finally, I'll refine it further with another facet, the content type. I only want documents which are of type HTML. Now I've refined my dataset. Thanks, and I hope you've enjoyed watching.